Okay, now let's discuss part 2. There was a bit of mistake which I corrected. Uh, it's the same, the only difference is that L is now, the rod is at an incline, and the distance for the tension at point B has been halved. This, the string has been halved uh, to a length of d by 2. We will similarly calculate the tension at point torque at point A, which is mg L cos of theta by 2. Well, L cos of theta, because now the length is not L, it's L cos of theta. And then similarly tau is equals to I alpha, and doing similar kind of calculations you end up at a value of 3g cos theta by 2 for the acceleration. Now the only thing left to find over is theta. Well, theta can be found at like so. L, if you look at this triangle here, this, if this distance is d by 2 over here, this distance is d by 2 over here, this distance is also d by 2, so you get that distance d by 2. Then you have this length L, and using sine inverse you can get d over 2L is equal to 21.43, and then simply plugging it back in gives you the value of acceleration, which is 13.683 meter per second. Since this was relatively quick, let's do another problem simultaneously, and this is an easy one too. This is the one relating to finding the moment of inertia about a central axis. Okay, we have these uh, three masses R, Q, and S. I think this is S. R, Q, and S. We have these three masses, and what we have to do is we have to find the moment of inertia about an axis which is 0, -2, 0. So it lies at point 0, -2, goes up into the z-axis. This is along parallel to z-axis. That's your axis. So we have to find the moment of inertia, the combined moment of inertia about this axis. Here's some data. This is the masses and their coordinates. Then you have the axis, and then you have this thing called the parallel axis theorem, which states that if you want to find, let's say, if you want to find, there is an object placed here, and you want to find, I'll call this the center of mass axis, and this I'll call the O axis. So if you want to find the moment of inertia about O axis of an object placed here, the first thing that you have to do is to find the moment of inertia about its center of mass, and then using this thing called the central axis, called the parallel axis theorem, you can then find it about any desired axis that you want to, given that you know the distance between the two, the center of the mass axis and that the axis you want to find the moment of inertia around. This is d. Okay, so we can calculate d pretty easily. These are the coordinates for each mass, and these are the coordinates of the new axis. So using these we can calculate d pretty easily using this formula, del x squared plus del y squared plus del z squared. Z component is not going to make any difference because z is 0 in all of these and z is 0 here too. So 0 minus 0 is 0, so it is not going to make any difference. So we can just ignore this in our calculations, and del x and del y will suffice. Now IR is 0.3, the mass comes from here, and then you can calculate the distance using this formula. It's 52, it's 17, and it's 41 respectively, and when you multiply these out you will get IR, IS, and IQ, and then the total moment of inertia is just IR plus IS plus IQ. That's it.